Good morning, children. Welcome back to the online session on pre-calculus topic. In fact, we had completed all the topics on pre-calculus. Today, what we are going to do is just a revision of class 11 sums on differentiation. Remember, the differentiation what you are going to do in class 12, it is just an extension of what you have done in class 11. So, we are going to revise and have a good look at all the good questions based on the exercise what is given in your 12th standard textbook, revision of class 11. So, children, I want to really work out with that, because the reason is, if you understand this, your 50% work will get over, because whatever the new things are put, there is e raised to x, log x, inverse differentiation is there, logarithmic differentiation, parametric, implicit differentiation. So, all this differentiation will be little bit handy for you all, little bit easier for you all if you have your basics of differentiation for class 11 as a strong part of understanding. So, children, let us begin with this particular part. Before we proceed, I just want to tell you that something is important in this. That is nothing but the formulas, the function is there, right? Now, if you see the function here, right, there is a function is given to you, derivative is given to you. So, x raised to n is nx n minus 1, n is not equal to 0. Derivative of a constant is 0. Please remember, I am repeating this. Calm, compose, patience will be your key for success. Okay, so constant derivative is 0. This is the power rule which you apply. Bring the power down and 1 less. This is not applicable when n is equal to 0. Finally, square root of x. Square root of x derivative. Actually, I am using the power rule itself here. So, square root x is 1 upon 2 root x. 1 upon x derivative using the power rule. These are some standard functions which we use very frequently. Its derivative. Okay, so that's why I just specifically just made a point to mention and write it down over here, and let us see what we get. Root x is 1 upon 2 root x, 1 upon x minus 1 upon x square, and some on the right hand side if you see, there is some a set of trigonometric functions and its derivative is happening here. So, I believe, I think you are aware of it. Sin x is cos x is minus sin x, tan x x square x, cot x is minus cos x square x, sec x is sec x tan x, and cosec x is minus cosec x cot x. Then very important thing is that if I missed out one thing, what you can add up to it now, that is if you can say if function is u plus v, then f dash is given as u dash plus v dash, plus or minus whatever it is. So, what I mean to say here is, when the two functions are separated by plus or minus sign, you find the individual derivative and go ahead. Now, this is number 1, this is number 2, and this is number 3. Very, very important part which will govern your working throughout the class 12 differentiation. Now, before we start with this topic, I want to tell you, children, this differentiation topic is a very, very important topic of calculus, because if you understand this differentiation topic properly of class 12, little bit vast, but we will go slowly, steadily, and ensure that you understand everything, how to approach the derivative for a function given in whatever form it is. If you understand this particular topic nicely, properly, fully, completely, then the next 3 topics, indeterminate forms of limits, mean value theorem, application of derivative, and of course, cannot forget it, maxima minima. These 4 topics will be in your pocket. That's why might be on the differentiation is a plain differentiation, there will be only one sum and you have n number of exercises. But the use of these exercises will be very much useful in understanding the next 4 topics after differentiation. So, basically a syllabus for differentiation is a cluster of 5 topics: differentiation, indeterminate forms of limits, mean value theorem, application of derivative, and maxima minima. So here we go, children. We begin with the class 11 revision. So I'll be just moving a little bit faster, but at the same time I will ensure that you really recapitulate what you've done in class 11. So let us begin with this wonderful topic. I had given you the functions and its standard derivatives. You can make a note of it. This is one set which you have to remember. First rule. Second rule. What is this function? Function is uv. Then derivative, product rule you call it. First derivative of second plus second derivative of first. Similarly, if fx is u upon v, this is called quotient rule. dy by dx will be v. Understand, denominator will be v square. V derivative of u minus u derivative of v. This is nothing but quotient rule. Now as we go on, I will definitely focusing on chain rule. Most important rule. Okay, so that also we will focus it on as we go on, and we will see how the sums comes up. So I hope you take it down properly, no mistake. As and when, I would just suggest leave the first page vacant and you can fill up this particular thing in that, and as we go on adding new function and its derivative which is connected with class 12 syllabus, those you can add up so that whenever you have a reference paper or reference sheet on differentiation, you have everything on one scale and you are able to recollect and recapitulate the time you want. Children, here let us go now. So I am beginning with the question. So let me tell you once again, we are recapitulating, revising the class 11 differentiation in its best perspective. So let us begin. The first question which comes up, simple questions, but you have to understand they are saying differentiate. All the sums are differentiate with respect to x. Okay, so dy by dx they are asking us. So even though they are not mentioned here, okay, so I will just press upon this. So if you can write y is equal to 6x squared, 6x raised to 8. Okay, so first thing is I want to find dy by dx. So either you write dy by dx or you can write y dash also. So dy by dx, the coefficient will remain as it is, derivative of x raised to 8. Now these steps you need not show in the examination, okay, so it is just a beginning, so I am just working out with this particular thing. Now what is the mean? Now, x raised to n. So by the way, if you see x raised to n, what is x raised to n here? The power rule nx n minus 1. So bring the power down and apply and what is it? Bring the power down and 1 less, the new power becomes 1 less. So what happens, let us see. So dy by dx, or as this y dash henceforth, y dash 6 coefficient will remain as it is, okay, and derivative of x, bring the power down and 1 less, that is 8 minus 1, that is nothing but y dash is nothing but 6 8 6 7 48 x raised to 7. Now these things you can do directly also, okay, because I am just showing you because this is just the beginning. So how I apply the power rule, remember the power rule is the most powerful rule in the differentiation. X raised to n is nx n minus 1, bring the power down and 1 less. So I hope you got this point clear. Let us take more an example. Then once again let us take this part also. So y is equal to 9 upon x. Now understand, you can take x up or you can do u by v and all this stuff, but I told you just now 1 upon x derivative is minus 1 by x square. Okay, that's very important. So pay attention now, with the power only I got that minus 1 by x square. So y dash is 9 is the coefficient derivative of 1 upon x. Remember, any coefficient happens to be there, you can always take back the coefficient outside and then take the derivative of the inside function, unless until it is a constant, plain or constant. So 9 derivative of 1 upon x. So just now I saw what is derivative of 1 upon x, it is minus 1 by x square. So here let us go. So y dash will be 9 derivative of 1 is minus 1 by x square, can be written as y dash is equal to minus 9 upon x square. You can leave it as it is because there is no need to do that. What I mean to say, taking x square up positive is power is always the standard way of noting the indices. Next is a very interesting thing. I'll just show you chain rule. Anyway, now right now I'll just work on with you now how it is. Now just see. If suppose if I denote this as y is equal to 7 into 1 upon x square. Now hold on, I am just showing you the working of this separately. Okay, listen very carefully. Now derivative of 1 upon x is minus 1 upon x square. Do you agree with this? Right. You can apply, either you take x raised to 2 up, okay, either you take x raised to 2 up and do x raised to minus 2, that's not an issue at all. You can apply the power rule, you get the same answer. But I am going to give you shortcuts now as we go on. Remember, as I am going on, you will be exposed to shortcuts, so I believe that understand and register in your mind. Now, understand, okay, 1 upon x is minus 1 by square. Now, basically, if I want to find the derivative here, now just a second, I will just complete this part. So, y dash is 7 into derivative of 1 upon x square. So, that is what I am trying to tell you what is exactly. Now, pay attention. Now, 1 upon x derivative is minus 1 by x square. Now, this function instead of 1 upon x, what is the function? It is 1 upon x square. Now, hold on. My x has been replaced by x square. So, in the sum, it will be minus 1. The x has been replaced by x square. So, this is x square. So, this is my x now. So, square. So, understand what I did? 1 upon x is minus 1 by x square. We will do many questions based on this chain rule. As you go on, you will evolve yourself. So, 1 upon x is replaced by x square. So, this x is x square square will become x raised to 4. Now, hold on, this was derivative of 1 upon x, this was derivative 1 upon, right. Then chain rule says into, what is the derivative of x square? 2x. So, chain rule comes up, you take the standard derivative and you take the derivative of the inner function. Don't worry, I will just get back to that later on. So, minus 1 upon, you can say minus 2 upon, I am sorry, minus 2 upon x cube. So, I got the working here. What is the derivative here? So, y dash will be 7 into minus 2 upon x cube. So, eventually you will get y dash is equal to minus 14 upon x cube. You have to adopt these techniques, standard techniques, just by comparison. Any function, 1 upon that function, derivative is minus 1 upon that function square. So, 1 upon function is minus 1 upon function square into chain rule f dash x, that is 2x. Power rule applied, x will bring the power down, that is the point. We will be doing this again and again in many questions, so just relax for now, but this is the way you get to know the basic sums I started with. We will venturing into more difficult sums as we go on from sum to sum. So, I hope you got this point clear, children. I would request you to quickly pause and note it down. If you understood, fine, you can proceed to the next sum. Otherwise, you can just pause and note it down properly, no mistake at your end. Effort, your effort will be rewarded to you. Write, do yourself. If you falter, the board is there. Remember one thing, after every fall there will always be rise. So, better today you fall, no problem at all. But you will get n number of opportunities to rise after every fall. So, please note it down, please, and then we will see the next set of sums. Okay, great. Next question comes up now. What is the question? Oh, a big set of questions, no problem. Now, I want to come here. So, remember, they don't mention that this is y. So, we understood this is a function. So, I can always write down, that is y is equal to square root of 8 minus 7x. Okay, chain rule. Okay, I'll just make you understand what is the chain rule here, so that you can really work out something on your own. What does the chain rule says? Now, for example, okay, I'll just explain with the help of trigonometric function. It will be more easier for you. So, suppose derivative of sin x. What is derivative of sin x? Cos x. Okay. Derivative of sin 2x. Understand? Derivative of sin is cos. Do you agree with this? Similarly, derivative of sin is cos only. Cos. Sin of anything is derivative of that thing. Sin of anything is derivative of that thing. Derivative of that thing. Hold on. This was derivative of sin, but there is an inside function. See, there is an algebraic function inside trigonometric function, right? In algebraic function inside. So first you found trigonometric derivative, and then by chain rule says multiply by the derivative of the inside function 2x. What is the derivative of 2x? 2. So which is eventually 2 cos 2x. Understand, there's something important. Every sum you have to look in. Here also you are doing that. Sin x is derivative of cos x, and what is derivative of x is 1. So that's why we don't mention it specifically over there. Now children, I hope you got this point clear. So let us take one more example if you want. Okay, I think as we go on we will see more and more questions on that. So let us talk about this, root of 8. So if you remember the root of 8, what is root of any function? It is 1 upon 2 root x. So root of anything, derivative is 1 upon 2 root that thing. 1 of something is minus 1 upon square of something. So understand the pattern like this. You have to learn it like that. Okay, so let us see this part clearly. Root of something. What is derivative of root of something? It is y dash is 1 upon 2 root 8 minus 7x. Now hold on. This was derivative of root because see, root x derivative is 1 upon 2 root x, correct? Right. The same pattern, root of anything is 1 upon 2 root that thing. Normal condition. And then by chain rule says into, pay attention now. Root derivative is 1 upon 2 root, go inside, that is the algebraic function. What is derivative of 8 minus 7x? 8 derivative is 0 and minus 7x is minus 7. So in short, y dash is nothing but minus 7 upon 2 root 8 minus 7x. Now you might say, why you not put 7? If it is plus 7, then derivative will be plus 7. If it is minus 7x, so derivative is minus 7. And remember, derivative of 8 is 0, constant, stand alone number. Derivative of a constant is always 0. Okay, I hope you know. Now your derivative is not 0 because this is the coefficient of x, not a constant. Okay, so first thing I think is very clear. The next thing comes up, 2 upon x plus 1 upon root x. Great. 2 upon x is very simple. First of all, let me write down in the sum format. It is y is equal to 2 upon x plus 1 upon root x. Okay, now listen. Either you find the LCM and then do it, or there is a plus or minus and individually you can take the derivative. So y dash will be 2 into derivative, coefficient I am taking it out, 1 upon x plus derivative of 1 upon root x. Just now in the previous question, if you see the previous question, I compared it, right? 1 upon x derivative is minus 1 by x square and 1 upon something is minus 1 upon square of that something, right? Minus 1 upon square of that something. Same thing here you have to do now. Understand? Okay, now look at this pattern here. 1 second, I'll just divide this out so that you come to know exactly what I am trying to do. Okay, now look at this pattern here clearly. What happens now? Okay, let us see. Y dash will be 2. What is derivative 1 upon x, children? Minus 1 by x square. So I have no problem with the first one. Plus. Now derivative of 1 upon something. What just now I said in the previous sum, derivative of 1 upon something is minus 1 upon square of that something. If you remember this part, I'll just tell you. See, 1 upon something is derivative is minus 1 upon square of that something. So what happens here? Minus 1 upon square of this something. What is my something? Root x. So root x derivative is nothing but x. I mean, it's not root x derivative, sorry. Minus 1 upon something is minus 1 upon square of that something. So square of root x is x. Now hold on. This was derivative for upon. 1 upon something is minus 1 upon square of something. Right? And into, you don't forget it, because this was derivative of upon, 1 upon something. Minus 1 upon square of the something. Into, if you see inside also there is a function root x. So what is derivative of root x? 1 upon 2 root x. That's it. You will learn this part as we go. Slowly, don't by heart it. I want to have a patiently work on the question. So I can just simplify this. Y dash will become minus 2 upon x square. Here, minus 2 upon x square. So minus 1 upon 2x root x. So this is my final solution. Let us take the next question now. Next question, you can take cos 7x. So again, y is equal to cos 7x. So y dash is derivative of cos 7x. Because the variable x is different with respect to x, keep that in mind. Simple now. So you know already we had seen derivative of cos x here. Derivative of cos x is minus sin x, correct or not? So derivative of cos x is minus sin x. So y dash will be derivative of cos 7x is minus sin 7x. Now remember, this is derivative of cos. Inside also there is a function. Into what? Chain rule. Whenever there is a inside function ke andar function, right? So I'll take one example and I'll show it to you. Now when we come to that. So 7x, that is derivative is y dash will become minus 7 sin 7x. I want you to apply yourself and don't copy the solution right away. I really want you to apply, because the more you are going to do it, children, on your own, I challenge you, you can challenge me with your intelligence. I always believe, remember, you are always an inspiration and you are always 10 steps ahead than what we are. And I want to be you there. I want you to be there, not here. Okay, so I hope you got this point clear. Let us take one more example. Sine of x square. Remember, there is a difference. This is different. Is this not the case? The sine of x square means the square belongs to x. So let us pen it down. Y is equal to sine of x square. So first y dash, I'll be going on directly. Sine derivative. Sine of something is cos of something. Just now I showed you that. And by chain rule, in trigonometry there is an algebraic function. What is the derivative of algebraic function? 2x. X square, bring the power down, 1 less. So power rule is very, very important rule. So y dash is nothing but 2x cos of x square. I hope you got this point clear. I want to show you that part of working. Might be next screen. I will just show you the chain rule. Again and again I will just show you about the chain rule. Okay, because that is very important rule which you have to carry on across. I hope you got this point clear, children. So pause and note it down. Let us see what lies ahead in the next example. Okay, great. Now here we go. There is a next example coming up here. X cube upon 3x minus 2. 1 plus cos x upon x. Now, if you look at all the previous sum, one term, plus or minus, and this thing. Now, in this case, if you look at this particular pattern, I told you these are the 3 important things which you have to keep in mind always. Plus or minus individual derivative. If the product of the functions are there, uv, then u derivative of the second plus second derivative of first. If it is quotient of something, then v square, v derivative of u minus u derivative of v. So keep that in mind. So let us proceed with the question now. So here if you see, it seems to me that this is a case of, right, Okay, before that I will just press myself into some chain rule techniques. Pay attention now. Okay, we will take it up as we go on. Sorry, let us begin with this. So first thing is, I'll just mention this is y is equal to x cube upon 3x minus 2. Now what you understand from here, if you understand this, that this is nothing but u upon v rule. I mean to say quotient rule we apply. Why? Because the function is given in terms of u upon v. In all the previous seasons there was single term, so I could find the derivative right away just to warm up myself with those function and its derivative. Now let us go one by one applying the product rule, quotient rule and u plus or minus v rule. So let us see this part. So everybody knows, in short, dy by dx, please listen, v square, I write this rule for you, v square, v derivative of u minus u derivative of v. I just mentioned this specifically so that you come to know exactly how we are going ahead with this question. So let us start. Dy by dx. First thing I will suggest is write the v square. What is my v here? V is 3x minus 2. So replace this 3x minus 2 whole square. Few sums you write like this, otherwise afterwards you can do directly also. So v derivative of u. What is my u? U is x cube minus u derivative of v. This is just beginning sums on u upon v. That's why I am specifying to you what is the rule we applied. V derivative of u minus u derivative of v. Whenever you see power, you first apply the power rule, nothing else. What is the power rule? Bring the power down and one less. So never forget that. I hope you can do that. Right? So dy by dx, or I can say y dash, 3x minus 2 whole square. Now hold on. Whenever you are applying the product rule or quotient rule, every term put in brackets. You will avoid common mistake with the children do by simplification. So let us see this as it is into derivative of x cube, power rule. What is the power rule? X raised to n. Bring the power down and one less. So 3x square minus x cube, bracket, don't forget it. Derivative of 3x minus 2, hold on, derivative of ax is a, and this is constant derivative is 0. I hope you remember this. Derivative of 3x will be 3 and derivative of 2 will be 0. And now simplify, because there is always a fight between the teacher and the student till what step you should carry on the simplification in any question. You carry on the simplification till you take out common and nothing. You can, algebraic part there is no problem to identify till what step you have to go. But I suggest go to the best of your ability of simplification on basic mathematics. Okay, so what does that mean? I will just show you. So if you can open this up, 3x minus 2 whole square, and what will happen now? This will become 9x cube minus 6x square minus 3x cube, which is equal to 3x minus 2 whole square, 9x cube minus 3, 6 common, this will become x cube minus x square. I hope it's working well. You can take x square also common, I have no issue at all. That will be more better for us to work on. One thing I want to share with you, the solution which is given to you here, the v square, in 99% sum we never cancel anything unless until you are able to cancel something completely from the numerator and denominator. Otherwise leave that v square as it is. Okay, but I hope you understood the grade of simplification. You can move ahead and do one more step also. Take x square common. So this becomes 6x square x minus 1 upon 3x minus 2 whole square. So I hope you got this point here. This is the actual specification working rule for u by v. Let us take the next question also now. So next question also comes up. So y is equal to 1 plus cos x upon x. And don't worry, whatever the function you have very standard format of rules to follow. u upon v rule, uv rule. So I don't think so you should have any problem in doing that. So first thing what I would suggest is, if you see this, identify what type of format it is. So this is nothing but u by v rule. So u by v rule, y dash, I am writing it here specifically, it is v square, v derivative of u minus u derivative of v. So let us begin now. Now y dash, v square, don't forget it, v derivative of u minus u derivative of v. So once you place yourself into this formula as it is, then it's just a cakewalk, because the level of derivative is very cheap. So y dash, this will be x square, x bracket, I told you never to lose out the bracket, into, what is derivative of 1? 0. Derivative of cos x is minus sin x, minus 1 plus cos x as it is. What is derivative of x? 1, because derivative of ax is a, so derivative of 1x is nothing but 1. So keep that in mind. So derivative of x is 1. You will learn as you go on, don't by heart, it is no need. As you go on, but when you are doing, do it actually. You go wrong while finding out, but do it. Okay, then only you will understand how really, where you are doing the mistake. That's identifying the mistake itself is a success. Keep that in mind. Okay, identifying your mistake. So coming to the point, I just simplify this out quickly. So y dash will be minus x sin x minus 1 plus, sorry, beg your pardon, there is a minus sign because the inside sign will change. So what will happen? Minus 1 minus cos x. I don't think so anything simplification is possible further, so this will end the solution here. So understand how we apply u by v, chain rule every time. You whenever a function ke andar function, andar ke function. I will give an example. See, suppose there are one box, inside there is one box, inside there is one box. So what you will do? First, to go to the innermost box, what you will do? First you will open up the outer box. So outer derivative, then inner derivative, then inner derivative. Okay, I will come to that when we see the situation here. Is here, there is not an issue at all. So I hope you got this point, children. So pause and note it down. Okay, I hope you got this point clear. Let us take the next question. Find, okay. Now I'll just add up something here. Okay, now it's a little bit better. Don't worry, I'll come to that question. It looks big, but it's the same thing what we are studying right now, what we are revising, same thing. So let us take this up clearly. So first thing, I told you, write in terms of y and then say bye bye. So y is equal to x raised to 4 plus 1 upon square root of 1 plus x. So definitely this is the case of quotient rule, because there is one function in the numerator and the other function in the denominator. So you can just go ahead with u by rule. So y dash, I am directly doing it now, listen very carefully, v square, v bracket derivative of u minus u derivative of v. Sorry to move out. So let us begin now. So y dash, I told you square root square is nothing but 1 plus x, and then let us go step by step, properly, slowly, patiently. Root of 1 plus x as it is. Derivative of x raised to 4 plus 1. So when there is a plus or minus, an individual term derivative will take. So x raised to 4 is 4x cube. And what is derivative of 1? 0. Constant derivative always 0. minus, now hold on, x raised to 4 plus 1, that's why just put a bracket, you will never go wrong, into, there is a multiplication, derivative of root of anything. What is derivative of root of anything? 1 upon 2 root x. So, it is 1 upon 2 root 1 plus x. Understand here, root derivative is 1 upon root of something is 1 upon 2 root something. So, it is 1 upon 2 root something, inside there is x only. So, derivative of x is 1, chain rule. So, I do not have to apply that here. Even though I applied, you are not applying it, but not showing it, that is what I mean. So, now hold on. Question arises, students ask me, sir, should we stop at this step? No. Why? I will tell you. Because if I find the LCM, root of 1 plus x and root of 1 plus x can get simplified here. Okay. So, that is why I do not want to miss out that part. So, if I find the LCM of the numerator, that LCM will go to the denominator. Is 1 plus x, do not forget it. It is 1 plus x. Okay, now hold on. See, 2 4s are 8, x cube, root of 1 plus x into 1 plus x, root of 1 plus x is 1 plus x minus x raised to 4 minus 1. You have a simplification skill. It will be 8x cube, denominator will remain as it is, remember here when I took the LCM, that LCM came to the denominator because that also denominator of the numerator will come join the denominator, that is why I took it directly here. So, now hold on, 8x cube, now this is plus 8x4 minus x4 and minus 1. What you can do is, after this, I know you do not want to do anything, but I would suggest be always a little bit standardized in your method of writing the solution. First write 7x4, then 8x cube minus 1. So, even you write this, nobody is going to say no, it is wrong. It is right, but I suggest just stick to your basic principles of mathematics. That is nothing but writing in the conventional form 7x4 plus 8x cube minus 1 upon 2 root whatever stuff it is. So, I hope you got this application U by V rule in general now. Going more and more some, do not worry, we are not in a hurry to finish up class 11. It might take one more lecture, but I would ensure that this basic background is very strong with you. Same thing again and again we are going to do till the end of derivative of class 12. So, even though you must have learned something little bit of it, no problem, as you go on and on, you will explore more and more and you will understand definitely more and more. Okay, keep that in mind. Excuse me. Now, here the question says, find the gradient. Look at the question. Find the gradient of. Find the gradient. Now, when I say gradient, means what? dy by dx. Gradient ka matlab hai slope, and slope of a curve which you have done in 11th standard is nothing but. Now, here if you see, there are two ways to do it. Acha, this is at 2 by 3. Now, do not worry about this point. I am not worried about this question. Okay. Then find the gradient of y. So, they are asking find dy by dx, slope. This you can say u, this you can say v. So, you know what is the product rule, right or not? You know what is the product rule. What is the product rule? The product rule says if a function is given in terms of uv, u derivative of second plus v derivative of first. So, I hope you understood this point, right. So, what happens here? Let us see. Okay. dy by dx, I am first finding dy by dx. U derivative of v plus v derivative of u. So, what I did, the first derivative of second plus second derivative of first. I think it's understandable. Then go ahead with the normal function here, dy by dx, x plus 1, I told you never forget the bracket, derivative of 2x plus 3, derivative of ax is nothing but 2 and derivative of constant is 0. So, it comes to plus 2x plus 3 and derivative of x is nothing but 1. My game is over. If you want, you can simplify this out. because this is not my final conclusion. It will be 2x plus 2x will become 4x, 2 plus 3 will become 5. So, let me do it, 2x plus 2 plus 2x plus 3, so 4x plus 5. Now, this is my general derivative, I mean to say at any value for x, right. So, dy by dx at 4x plus 5. Now, if I want to find the specific, see, look at the question, find the slope at this point. You know what does that mean? Suppose I am not presuming it is a parabolic shape, x square equal to 4ay. So, x square equal to 4ay, something here, the x square equal to 4ay, it can be here, it can be here somewhere, okay. I am not authenticating the graph here. So, at 2, 3, now suppose this is 2 and this is 3. At this particular point, the slope, at this particular point, they are asking you the slope. Now, just to presume the diagram happens to be this way, otherwise, whatever diagram comes up, the meaning of this is at 2, 3, this is 2 point, this is the coordinate 2, 3. So, at 2, 3, what is the slope? Okay, keep that in mind. So, this is just for your understanding, I share with you, but this is the general slope. Now, what I will do is dy by dx at what point you want? At you want 2, 3. At point 2, 3 will be equal to, now understand, 4, 2, 3, this is my x, this is my y. So, 4 into 2 plus 5, which is nothing but 8 plus 5, 13. So, the slope value is 13 when at this point 2, 3. So, whatever the curve is there, the slope at this particular point is 13 value. Derivative, slope, gradient means slope, keep that in mind. So, question, don't panic, it is the same thing what we did, just the extension. Instead of finding a general slope, they will say find the derivative x equals to 1, put the x value in the end and that is the point, that is over. I hope you got this message clear, right. So, pause and note it down, we will be seeing a lot of questions further, might be some break is waiting for you, a 2 minutes break I will give you, because otherwise you say, sir, what is that, you are going like a rocket speed, you are moving out. So, pause and note it down, children, let us see this part clearly. Oh, one more set. Okay, now here also a simple question now, fx is given to you, this find the value of a given f dash a. Hold on, I want to tell you, remember if the y function is there, the derivative can be written as y dash, derivative can be written as dy by dx, derivative is also written as f dash x. So, it is one and the same thing, keep that in mind. So, here we go, let us begin. Fx is given 3x square minus 4, find the a value of a given that f dash a is equal to 5. So, from here, remember this is fx, correct? Can you find f dash x derivative? Yes, I can find f dash x very easily. So, f dash x I am doing directly now, 3 as it is, bring the power down, 2 3s are 6x minus 4. This is my derivative of this function. Now, once I got the derivative of this function, that is f dash a is equal to 5, find the value of a. So, f dash a, tell me what is f dash a? F dash a is given as 5. So, f dash a, replace x by a. So, f dash a what it will be? It will be 6a minus 4 is equal to 5. I hope you got this point clear. See, f dash x is 6x minus 4. So, f dash a will become 6a minus 4, which is value of this is given as 5, it is given already. Push up and find the answer. So, a will be is equal to 9 upon 6, which you can also say 3 by 2. So, the final solution can be 3 by 2. I hope you got this point clear. Right, children? So, it is not difficult, you have to be careful about what you are doing. Okay, now chain rule I will explain. This is a better example of chain rule, because there is a single term function. So, I have no issue. I will just present it properly. So, presenting it properly would be this way, y is equal to this square. So, this I can write as sine of 3x plus 5 whole square, right, because there is sine square, there is a difference between sine square x and sine x square. That is the difference. This is square belongs to this. Here the square belongs to the complete trigonometric set. Now these smaller minute things I am explaining again and again, because as you go on you should not get hooked up because of these silly things. Now here first, now let me find the derivative. As I said, as we are going on doing the previous questions, I told you, I explained to you that whenever you have a square, whenever you have a power in the derivative function, to find the derivative, first find the derivative of that power. So if this I take as x raised to n, so what is our derivative? Bring that power down, 1 less. So nx n minus 1. So y dash, hold on, I am doing this. First derivative of this power, twice of sine of 3x plus 5. So this is the derivative of power. Bring the power down. This I consider as x. So x raised to n. Nx n minus 1. 2 minus 1 is 1. I have no issue. Into, now see, chain rule says whenever your function, inside function, then you open up the outermost box. Here the outermost box is power. So I find the derivative of the power. Then I go inside. Inside what is that? Sine. First find the derivative. Sine of anything. What is sine of anything? Cos of that thing. And I am surprised to see inside one more function. Algebraic function is also there. So 3x plus 5. It is 3. Derivative of 5 is 0. So I repeat. This is sine. I just wrote sine 3x plus 5 whole square. First find the derivative of power. Then go inside. Multiply by cos. Then go inside, multiply by 3. So now you can just simplify this out whatever you want. Now what you can do, there are many ways to do this sum. 2 sine theta cos theta. If you remember, if you do you know this rule? Sine 2 theta is 2 sine theta cos theta. This you have done in class 11, correct or not? Sine theta is equal to, this is not 8, please, that is sine. So sine 2 theta cos theta is 2 sine theta cos theta. Now 2 sine theta, if you pay attention here, 2 sine theta cos theta. What is 2 sine theta cos theta? So y dash sine of 2 theta. So 2 sine theta cos theta is sine 2 theta, and this 3 you can just place it. If you want, you can take it inside, which is nothing but 3 sine of 6x plus 10. So even though you don't take it inside, fine, but any way of writing is fine with this particular part. So I hope you got this point clear, right? The first is a slightly different nature of question. The second one is a good example for applying for understanding the chain rule, children. So pause and note it down and enjoy the sums. Yes, one thing I want to share with you, these sums are based on your first exercise, first and the second exercise. So whatever we are doing today and next session, it will be based on the first and the second exercise. Okay, many sums are from the exercise one, so it's you can have a look at that particular sums also, which I have not done, but picked up good and difficult sums. Okay, not difficult one, knowledgeable sum, because there is a revision. I want to recapitulate and bring you back to differentiation, which you have done around 3 to 4 months back, right? I hope 4 months or more than that also.